area. This compares the complete characteristics of LED and LCD. So it consumes more power. It requires 10 to 250 milliwatt per digit. So per digit it requires, because the LED has to glow bright. So when the LED has to glow bright, the amount of current which you drive a LED has to be more, and more bright the more power it consumes, right? So one digit it requires 10 to 250 milliwatt, but LCD is essentially a capacitor. It consumes very less power, of in the order of 10 to 200 microwatt per digit. So per digit the power consumption is only 10 to 200 microwatt for LCD. So if you see 7 segment display into 7, so 10 means it will become 70. So minimum 70 milliwatt it's required, but here I require 70 microwatt minimum. So it is 1,000 times lesser. So that's why we say LCD is power efficient, whereas LED is going to consume a hell a lot of power for your application. Because of high power requirement, it has to be driven only from ICs. So you have to have a huge amount of current to drive your LED. So unless your ICs are going to provide such a huge amount of power, your LEDs cannot display the things perfectly. But you can directly drive LCDs from IC chips. But LEDs cannot be driven directly from IC chips because the current requirement is very, very high. You need minimum 10 milliwatt of power. So that requires a huge amount of current to produce 10 milliwatt of power. And the brightness, when you come to brightness, obviously LED will score well. The brightness of LED is very good, but LCDs are moderate. They are very dull in terms of brightness, and they can no way come near LCDs in terms of the brightness. And LEDs can operate from minus 40 degrees to 85 degrees Celsius without any issue, whereas LCDs can operate from minus 20 to 60 degrees Celsius. So lifetime is 1 lakh hours. So if you use properly with the drive circuitry and if you well maintain your LEDs can survive till 1 lakh hours. Whereas LCD, the lifetime is limited to 50,000 hours due to chemical degradation, because you're frequently aligning the crystal molecules and realigning them by applying voltage. Frequently you're doing that, or applying voltage, they are aligning. When you remove the voltage, they are randomly aligned, right? So frequently we are aligning and realigning these liquid crystals inside the LCD. So the lifetime is going to be very, very limited. It is just half of that for an LED. So the LCD will last for 50,000 hours because of chemical degradation. The liquid crystal start degrading when you use it more and more. Okay, so emits light in all possible visible colors and invisible colors also: violet, indigo, blue, yellow, orange, red, green, ultraviolet, infrared. So it emits preferably in all visible colors as well as in UV and IR. But if you see in LCD, it is invisible in darkness. So when you keep an LCD display in darkness, it is invisible. It requires external illumination to see what the LCD is displaying. So in normal lighting conditions, you can clearly see the LCD, what LCD is displaying. But when you are in darkness, you cannot even see what the LCD is displaying, and it requires external illumination. So the operating voltage is 1.5 to 5 volt DC LED, and the response time is very good, nanoseconds. So as moment you switch on your LED, you can see the light getting emitted. Such is the fast, swift nature of your LED. But LCD, you see, it is operating in AC, 3 to 20 volt AC, and it has a very slow decay time. The response time is 50 to 200 milliseconds. That's what we have said. The turn on and turn off time is very, very larger, which makes it a slow device. It is very, very slow. Viewing angle 150. When you view at 150 degrees, you can get maximum. You can see the maximum brightness coming out of your LED. And for LCD, the viewing angle is going to be 100 degrees Celsius. So this will clearly summarize the properties of LED and LCD, and we can see there are applications still using LED and some applications still sticking to LCD, and you cannot completely say which one is better. So it is not the question of LCD or LED is better. So they have their own pros and cons. So see the application which is what is the requirement of the application and use it accordingly. So even now, when you interface any device with the microprocessor or microcontroller, LCD displays are more preferred because they are very easy to code. you can easily code in C program for the LCD, for the turning on and turning off the LCD. Even for LEDs also you can do the same thing. But instead of LED displays, LCD displays are popular when you are going to interface some values, or when you're going to display some value from a microprocessor or microcontroller. LCD displays are still being preferred even now. Okay, and only drawback is the time, the slow response. That is the drawback, and the lifetime is less, and the brightness. You in dark you cannot see what the LED LCD is conveying to you, but as LED it is going to be bright. So even when the environment is dark, whatever the display shown by LED will be clearly visible. And the viewing angle, that is fine. So the major thing, but power consumption, if you see, LCDs are very good in saving power. So they require power only in the order of microwatt per digit, whereas LEDs require milliwatt power per digit for their for display applications. And lifetime and the light emitting, here you don't in LCDs we don't have any color, because we don't do anything with lambda, we don't do anything with wavelength, because we are just going to transmit or reflect light. If we are going to transmit light, it is the liquid crystal is going to become transparent, right? If we are going to scatter light, the liquid crystal is going to be opaque and it is going to become dark, correct? So there is no concept of lambda in LCD. It is going to be white and dark. And even that white and dark is because of applied voltage and the transparent and opaque nature of the liquid crystal display.